So what is an isotope? Well, imagine you've gone mining and you've found two examples of coal. Coal is pure carbon. You've got this one here on the left and this one here on the right. And you take them back to the lab and they react completely identically. They both burn to give carbon dioxide and water and give off heat. They look the same, they smell the same, they look identical. But in actual fact, these two samples contain carbon and these two carbons are isotopes of each other. So an isotope is an element with the same number of protons but different numbers of neutrons. They react chemically identically because it's the number of electrons and the way they're arranged that tell you how something reacts. So if we look at the electrons on this sample, it's got 2 in the inner shell and 4 in the outer shell. And this sample here has got 1, 2 in the inner shell and 1, 2, 3, 4 in the outer shell. So these two samples of coal will react completely identically because it's the electrons that tell you how something reacts. But if you take a closer look at them, the sample on the left hand side has got 1, 2, 3, 4, 5, 6 neutrons. And it's got 1, 2, 3, 4, 5, 6 protons. The sample on the right, however, has 1, 2, 3, 4, 5, 6 protons, but it has 1, 2, 3, 4, 5, 6, 7 neutrons. So these are isotopes of each other. 6 electrons, 6 protons, 6 neutrons. This one, 6 electrons, 6 protons, 7 neutrons. So if you're going to write this, the atomic number is the same because they both contain 6 electrons. More importantly, they contain 6 protons. Remember, the atomic number is the number of protons that an element has. So the bottom number is going to be 6, 6. And the top number is the number of protons added to the number of neutrons. So on the example on the left-hand side, it's going to be 12. But an example on the right-hand side, the number of protons added to the number of neutrons is 13. So an easy way to spot if two things are isotopes of each other is to look at the bottom number. And if the bottom number are the same, they contain the same number of protons in the nucleus, so the two things you're looking at are isotopes of each other.